That's Constanza, my daughter, and my #1 cheerleader. All right, so during COVID, millions didn't get a vaccine in time. Not because we couldn't make them, but because we couldn't keep them stable. Entire regions, especially developing countries, were left out of reach. And the reason was that pharmaceutical companies didn't have the tools to predict and prevent vaccine degradation from happening. Hi, I'm Hector Medina, CEO for Monte Caldera Technologies. And we believe that the world won't be able to tackle the most pressing challenges around global health and climate with just incremental improvements. We need 10x scientific breakthroughs. And science is not the real barrier. The challenge, the barrier here, is translating science to real-world, actual solutions. That's what we do. We developed a materials modeling platform grounded in applied physics, math, and AI to translate fundamental discoveries into real-world impact at scale. Those vaccines that I just mentioned were developed by a trial and error process in a lab. It is painfully slow, extremely expensive, and requires a lot of resources. Companies need to run thousands, sometimes even millions of combinations just to find that right formulation. That is a lot of time, a lot of money, and a lot of emissions to the environment. And that is also the reason why some critical technologies related to better medicines, batteries, cosmetics take years, sometimes even decades, to reach us. Now, that challenge behind those unstable vaccines shows up everywhere. Paints and coatings releasing toxic vapors, cosmetics and foods struggling with shelf life, batteries and polymers failing in unpredictable ways. All of these materials are known as amorphous materials. And they're pretty much everywhere we look. And understanding how amorphous materials behave at their molecular level has been one of humanity's toughest scientific puzzles. Think of it as trying to bake the perfect cake. You probably would need to go through 99 failed attempts that looks like this one until getting to the perfect ideal cake. There is a lot of trial and error and a lot of waste. We are changing that. Not by running more trials and errors or building huge, massive data sets to feed into black box AIs, but to going straight to the source to understand the physics of the materials. A theory we developed called Nestle, which predicts for the first time accurately how this type of amorphous materials behave at a molecular level before anyone mixes a single drop in the lab. That means skipping all of those 99 failed versions and go straight to the one that works. That is weeks instead of years, up to 95% less emissions, billions saved. Nestle is a set of mathematical equations and physics algorithms performed precisely to accelerate the whole R&D process. And we put all of this science into the Caldera engine, a digital lab that enables scientists to design and test materials virtually, from protein solutions to chemicals to special alloys, everything in a fraction of the time. And this unlocks a massive opportunity, a 60 billion market where the race for the discovery for new and better materials is the name of the game. We are a team of 14 PhDs in applied physics, mathematics, and nanotechnology, building upon a 40-year legacy of scientific research led by Professor Medina, who is the father of our academic family, but happens also to be my dad. I love you, Dad. This represents an entire lifetime of work in science. Luis Elizondo, our CSO, he is an experienced theoretical physicist with over 10 years of experience in academia and working over 6 years at the German NASA, and I bring over a decade of management consulting experience. Our core team are the scientists behind the development of the Nestle theory, and we are advised by esteemed researchers from multiple universities, national labs, and industry leaders that have already successfully translated cutting-edge science into real-world solutions. Our business model goes around our Nestlé proprietary technology with two main revenue streams: a highly scalable SaaS platform aimed at enterprise customers with average contract values ranging from $60K to $500K, and a royalty-sharing approach with the strategic partners, such as, for example, PPG, which is a Fortune 500 company and with whom we are already conducting pilots. Paid pilots, by the way. So far, we have raised $800K in pre-seed and joined prestigious programs like Techstars, Mass Challenge, Endeavor, among others, and backed by important organizations from universities to foundations. Now, we are looking to scale our Caldera engine globally and to reach every materials lab in the world. As you can see, we are not just reshaping R&D. We are building the future of sustainable materials in biotechnology, aerospace, health, cosmetics, energy, and beyond. Because every time a new material is created, 99 fail before one works. At Monte Caldera Technologies, we are here to find that one equation at a time. Thank you.